Welcome to The Explainer. Today, we're tackling a massive, fundamental question. How do we actually measure the health, size, and success of an entire economy? For all you focused learners and A-level economics students joining us, we're going to be looking at the ultimate economic yardstick, gross domestic product, and what it really means when people talk about economic growth. Okay, let's dive into this. Here is our roadmap for today. First, we'll pin down exactly what GDP is. Second, we'll tackle the mathematics of growth. Third, we'll be measuring across time using real data. And finally, we'll compare the world to see how global superpowers actually stack up against each other.
So, Section 1, what is GDP? The snapshot.
Gross domestic product, or GDP, is essentially the sum of the value of all goods and services produced in a country within a single year. Practically speaking, economists calculate this by taking the price of a good, multiplying it by the quantity produced, and then adding that up for absolutely everything an economy creates. And we aren't just talking about physical stuff rolling off an assembly line. This includes services, education, even research and development. It is the absolute grand total of a nation's output.
To visualize what economic growth actually looks like, let's imagine a hypothetical country. In year 1, they have a set baseline of production. But look at year 2. Their capacity has completely doubled. They're producing twice as many goods and services just 1 year later. Because they are churning out a significantly larger amount of output, we can definitively say this economy has fundamentally grown. That is the core intuition here. It's simply measuring how much more an economy can produce compared to what it did before.
Now, there's a super crucial distinction we need to make right off the bat: the annual snapshot versus tracking over time. When we calculate GDP for a single year, that's just a snapshot. It tells us the exact size of the economy right then and there. But economic growth, that requires analyzing the change in GDP over a time series. We have to compare the numbers from one year to the next to actually observe that growth taking place in the real world. Moving right along to Section 2, the mathematics of growth. We need a mathematical way to read the changing ticks on our economic yardstick. To do this, we use the percentage change equation, which you'll often hear called the growth rate. Let's break this down into 3 really simple, approachable steps. Step 1, take your new figure and subtract the old figure. Step 2, divide that result by the old figure. And Step 3, just multiply the whole thing by 100. Boom, that gives us our percentage change. Let's test this formula out with a hypothetical scenario. Let's say in year 1, our country's GDP is exactly $1 billion. By year 2, the GDP has bumped up to $1.4 billion. So we plug those into our formula. The new figure of $1.4 billion minus the old figure of $1 billion divided by that old figure of $1 billion multiplied by 100. Now, what's really interesting about this is when you run those exact numbers, you get a positive 40%. Going from $1 billion to $1.4 billion means the economy is actively expanding with a massive 40% economic growth rate. Which brings us to Section 3, measuring across time. Let's look at a historical application. Let's map out some actual historical data for the United Kingdom right at the turn of the millennium. In the year 2000, the UK's GDP sat at an even $1 trillion. By the year 2001, just a single year later, the UK's GDP had risen to $1.1 trillion. If we apply our trusty percentage change formula again, taking the new figure of 1.1 trillion, subtracting the old figure of 1 trillion, dividing it by 1 trillion, and then multiplying by 100, we land squarely on a 10% growth rate for the UK from 2000 to 2001. So the crucial point is understanding what that 10% actually means in the real world. It directly translates to the UK producing 10% more goods and services than they did the year prior. The UK economy fundamentally grew by 10%. And it perfectly highlights how economic growth is strictly measured from year to year within a specific time series like 2000-2001. Section 4, comparing the world. Let's take our mathematical ruler out onto the global stage. This naturally leads us to a pretty fascinating question. How do we stack up against the rest of the world? By calculating economic growth rates for different countries over the exact same time period, we suddenly unlock the ability to make powerful, direct international comparisons. And this brilliantly illustrates the power of that comparison. If we look at the 2012 economic growth rate for 2 global superpowers, we see the UK had a growth rate of 1.5%. But in that very same year, the USA experienced a growth rate of 2.5%. The data clearly shows us that while both economies were absolutely growing, the USA's growth rate was outpacing the UK's during that specific window. So, why do economists obsess over these metrics? Well, you can kind of think of it as the global investor's guide. These direct comparisons reveal relative national performance, which acts as a completely critical tool for anyone looking at the broader macroeconomic picture.
Let's see how this all builds our complete understanding. Calculating economic growth gives economists a seriously powerful multi-tool. It allows us to understand a single country's growth over time. It lets us make direct performance comparisons between completely different nations. And, crucially, it helps guide massive cross-border investment decisions. If you're an investor looking across different borders, knowing exactly where growth is accelerating is absolutely vital information. As we wrap up this explainer, I want to leave all of you, especially those A-level students mastering this syllabus, with a thought-provoking question to ponder beyond your textbooks. If our very definition of economic growth relies on constantly producing more goods and services every single year, what are the long-term limits of endless economic expansion? Can we realistically produce more forever? Something to think about. Thanks so much for joining me. Keep asking great questions, and I'll catch you next time.